Welcome to Calculus Solutions, where you will find limits, derivatives, integrals, and practical applications. Let's solve this integral. This is the integral of the function 3x squared minus 6x plus 1/2 dx. We can see that this is a polynomial of the second order. In other words, it's a quadratic expression. How do we start? When working out the integrals of polynomials, we need to focus on two things, namely exponents and constants. We have here the square, linear term, and a constant. In front of each term, there is another constant, namely 3 and minus 6. Now we need to apply a formula for integration of the polynomials. We will use the standard formula. It is simple and confusing at the same time. It is simple because the only relevant thing here is the exponent. There are two confusing things here, especially for the beginners. First, the value of the exponent will appear in two places. The value of the exponent itself will become greater by 1, and at the same time, n plus 1 will appear in front of the expression in the denominator. The second thing that is often forgotten is that the indefinite integral always produces what we call the constant of integration. Please never forget to add this, since this is extremely important for practical solutions. You will find such cases in my other videos if you wish. We will now do the same technique 3 times, because in our function we have 3 terms. The second power will become the third power. But do not forget to put the constant 3 into the denominator in front of the expression. Then the linear term, the power of 1, will become power of 2, and the number 2 will appear in the denominator in front of the expression. And the last term, the constant, will produce the linear term, just x. How come? The reason is that you can imagine x to the power of 0 to be present. And x to the power of 0 is equal to 1, so this does not change anything in the original expression. 0 in the exponent turned into 1, simply following the rule for integration of polynomials. And at the end, please never forget to add the constant of integration. The last step is to combine all the constant. Then the result will be x cubed minus 3x squared plus x over 2 plus constant. Let us visualize this situation. In this picture we can see the graph of our original function. It is a polynomial of the second order, and the graph is a nice smooth curve parabola. If we plot its integral in the same graph, we can see many interesting features and relationships between the original function and its integral. For example, at the points where the original function crosses the x-axis, in other words, where it assumes 0, its integral has the stationary points. At the point where the original function has minimum, its integral has its point of inflection. But there are many other relationships between a function and its integral. They vary from case to case. We will explore them in other videos. But let us stop at the constant of integration for a minute. In this case, I showed the solution for constant c equals 0. However, this constant can be anything. For example, if the constant is equal to 4, the solution will look like this. The curve will be a bit higher. If the constant is equal to 10, the solution will be positioned even higher. And if the constant is equal to minus 5, then the solution will be positioned lower. This constant simply moves the solution along the vertical axis. You may ask, which one is correct? The answer is that all of these solutions are correct. The exact value of the constant of integration comes from initial or boundary conditions, which depend on the real case. Please never forget about this constant of integration. So we solved it. Leave a comment, subscribe, and keep practicing calculus.